So in this video, I'll be graphing the natural logarithm function f of x is equal to 3 times the natural log of x minus 1. So we're going to start with the parent function. And remember that the parent function of a logarithm is just y equals log base a of x. So it's just the log with the base of x. So in this example, since it's the natural log, we know that the base is e. So the first step is to change it to exponential form, which I did here. So e to the y is equal to x. And then what I did is I chose values for y rather than choosing values for x, because it's much easier to choose the exponent and raise e to that exponent than it is to figure out a number and then what power would you raise e to get that number. This is especially true since e is an irrational number whose decimal goes on forever. So that's the parent function. Now what we want to do is we want to transform this function. And I'm going to go ahead and graph the parent function just so we can see the transformations. So we have 0.14, negative 2. Sorry, let me switch for my highlighter. We have 0.37, negative 1. We have 1, 0, so there's our x-intercept. 2.71 and 7.392 is going to be off the coordinate plane. So be careful when you're graphing these logarithmic functions. Because we chose values for y to get x, we kind of work this table backwards. It would be easy to accidentally graph the points backwards. But when you go to graph it, you kind of have to write yourself again and make sure you plot the points in the right order. So that's the parent graph, and that's the graph of the parent function. It has that same logarithmic shape, and it is an increasing function because e is greater than 1. So now if we look at the original function we're given, remember that the first thing you do is look inside, and the first transformation I see is there's a minus 1, so 1 is being subtracted from x. This will actually shift the graph right 1 if you remember your transformations. So what I'm going to do is I'm going to take my table of values over here, and wherever there was an x, I'm going to subtract 1. So 0.14 minus 1 is going to be, I'm going to add 1, not subtract 1, because we're going right. So 0.14 plus 1 would be 1.14. 0.37 plus 1 would be 1.37. 1 plus 1 is 2. 2.17 would be 3. Plus 1 would be 3.7. And 7.39 plus 1 would be 8.39. Then I'm just going to rewrite my y values. So the next transformation I see is the 3 outside. Since it's outside and not inside with x, that is vertical. Vertical transformations do what you would think, so a 3 is going to stretch it since it's being multiplied times the natural log. So that means I'm going to take my y values and multiply by 3. So I'm going to take y and multiply by 3. Here I took x and added 1. All right, so negative 2 times 3 is going to give me negative 6. Negative 1 times 3 would be negative 3. 0 times 3 is 0. 1 times 3 is 3, and 2 times 3 is 6. Now if I rewrite my x values, and those are the only transformations on my function, so I'm ready to graph the transformed function. So I'm going to go 1.14 down to -6, 1.37 down to -3, 2, 0, 3.7 up to 3, and then 8.39 up to 6 is going to run into all this. So I'm just not even going to graph that one. So we can see this function here is our transformed function. And it's actually going to come way up here to 6. So hopefully if you compare the blue function to the red function, you see that it's been shifted right 1. The x-intercept moved from 1, 0 to 2, 0. And it's been stretched. So this so these points have been stretched down. So this point is now down here, this point's down here, this point's now way up here, and this point is way up here. Notice that when you push a logarithmic function left or right, the vertical asymptote is going to be pushed with it. So normally the vertical asymptote of a logarithmic function is x equals 0, but since this graph was shifted right 1, the vertical asymptote is now at x equals 1. Not only, so that also affects the domain. So the domain of a logarithmic function is usually 0 to infinity, but because it's been pushed right 1, the domain is now from 1 to infinity with a parenthesis at 1. But the range is still -infinity to infinity. And we already talked about the vertical asymptote. So that is the graph and the corresponding transformations and how it affects the domain and the vertical asymptote.